Alright, on this video we're going to look at example number 6, okay, from the notes, the chapter 3-5 notes, and we're going to be using the equations of motion. Example. Alright, so the key to these problems is to figure out what is given to you and what is not given to you, like what you need to solve for, and which of the 4 equations we're going to need to solve the problem. So let's look at example number 6. A car moving at 25 meters every second slows to a speed of 5 meters every second while traveling 60 meters. Calculate the acceleration of the car and the time for it to slow. So let's underline what's given here. A car is moving at 25 meters a second. Okay, so that's what's currently moving at. It slows to a speed of 5 meters every second while traveling a distance of 60 meters. So the initial velocity of the car is 25 meters every second. It slows to a speed, so its final velocity is 5 meters every second. While traveling a distance, okay, we can call it either displacement or distance. Let's call it distance for now. While traveling a distance of 60 meters. Okay, so here are our givens. Calculate the acceleration of the car. We're going to find acceleration and the time for it to slow. So, looking at our 4 equations that we are using, we need to have the acceleration included in the equation, because obviously that's what we're solving for, and needs to have these variables only in it. Okay. So, looking at my various equations, sometimes there's more than one you could use, but I see that we have an equation VF squared equals, it's the third one, VI squared plus 2 times A times a displacement. Okay, so this displacement here would end up being this distance. So it can be a distance or a displacement. We're kind of using the terms as synonyms here right now. But in this equation we have VF, okay, we have VI, we're solving for A, and we have a distance or displacement. So first thing we're going to do, so here's our equation with variables. The first thing we're going to need to do is solve for the displacement here. Oh, I'm sorry, solve for A, because that's what we're solving for. So I need to solve for this right here. So by showing our steps here, we have VF squared minus VI squared equals, I just subtracted VI squared on both sides. I'll show us the intermediary step here on this next one. Next, I want to get A by itself, so I'm going to divide by 2 times delta D. Right, the 2's cancel out, the delta D's cancel out, and I have A on the right side. That's what I want. So now A is now equal to VF squared minus VI squared over 2 times delta D. I believe this is a problem that we did earlier in this unit as an example problem. Okay, so now we have our variables. Let's check VF, VI, and displacement. Those are all of our givens here that we have. So let's put the numbers in. VF is 5, so we need to square that. So 5 squared minus 25 squared over 2 times a displacement of 60. Okay, so we'll calculate that out. You end up with negative 5.00 meters per second squared. So we have the acceleration done now. Now let's find our time. there's a couple ways we can do this. We can use this acceleration in another equation to solve for time. I don't recommend that just in case this answer is wrong, because if this answer is wrong when you solve for time, then your time will be wrong as well. So let's just find another equation of motion here that we can use that relates the variables that we have. Okay, so we need to relate time, and we know VI, we know VF, and we know a displacement or a distance. So we have these four variables that we can use. We have to include the t because that's what we're solving for. And equation number 2 looks like we have a match here, that the distance traveled is equal to 1/2 times VI plus VF times t, and there's our t that we're going to be using. So let's rearrange this equation to solve for t. We'll multiply by 2 on each side to get rid of that 1/2. VI plus VF times t. And we'll divide by the quantity VI plus VF. I'll cancel that out. And I'm just going to rewrite this over here. T is equal to 2D over VI plus VF. Let's put the numbers in here. We end up with 2 times the distance, 60, over VI is 25, VF is 5. Simplify this, 120 over 30. Time ends up being 120 divided by 30 is 4. So 4.00 seconds. 3 sig figs, 1, 2, 3, 1, 2, 3, 1, 2, 3. Round the answer to 3 sig figs and use proper units of seconds. So here are answers here. Alright, so this is an easier problem. The next video on here will be regarding the previous problem, actually example number 5, which is a little tougher. So have a good day.